Steve Reyes, Product Manager for Anritsu. And today what we're showing is at the IMS 2019 show, a technology demonstration on how we can utilize the Anritsu nonlinear transmission line modules to go up to even higher frequencies than we have done into the past. So in this system, what we are doing is spanning from 70 kilohertz to 220 gigahertz. And we're doing that in a single sweep and doing it through probes for on-wafer measurements. So what we have been doing with these nonlinear transmission line modules is combining both the frequency generation capabilities as well as the down converting capabilities to span up into the millimeter wave range with excellent dynamic range, stability, directivity, and other performance. In the 110 gigahertz module, what we do is we bring the baseband frequencies from 70 kilohertz up to 54 gigahertz, and then we multiply from 54 gigahertz up to 110 gigahertz and couple that onto the main transmission line. So we have a DC path going from the test port all the way back to the VNA, which means we can utilize all of the benefits and capabilities of the baseband VNA as well as combine that with the millimeter wave modules. In the receive section, we are down converting from 30 gigahertz all the way up to 110 gigahertz. And that's coming out of the IF ports and going back to the baseband VNA for final analysis. The 110 gigahertz module has the 1 millimeter connector on it, and people are very familiar with the 1 millimeter connector operating up to 110, 120 gigahertz. And so you would have coax cal kits, etc. But in order to get to higher frequencies, which everybody has been asking for, we would have to change the connector geometry, which is what we did for the 145 module. So for the 145, in order to go beyond 110, we used and developed a 0.8 millimeter connector. We included a cal kit, verification kit, and the whole connector family with adapters, etc., in order to support that. But we found that many people are only doing on-wafer measurements as they go beyond 110 gigahertz. So after the launch of our 145 system, we have continually gotten requests to go beyond 145 up into the next waveguide band. And so that's what we're pursuing now with this new technology. And we are now developing a module that will go up to 220. So it's the same concept. We're starting with the baseband system, 70 kilohertz up to 54. We have our multipliers source. We couple that onto the main transmission line, so there's still a DC path back to the VNA. Now, we've added additional source multipliers to get up to 220 gigahertz. And by the same method, we are down converting from 30 gigahertz up to 220 and sending the IF signals back to the baseband VNAs. So the primary difference then, what we're doing now, instead of supporting connectors, we are now going to a direct interface to the probes. So instead of developing a 0.6 connector, we have developed an interface that directly accepts our probe. It still has a center pin in the inside of the airline, and so it's still a pin DC coupled type of connection, but it's without the threads. So of course then the primary benefit of such a broadband sweep is for device characterization. That's why people have been really in need of an ultra wide broadband sweep, is for device characterization. As they start developing these other high performance communication systems, they need to characterize their inductors, capacitors, resistors at extreme broadband conditions beyond 110 gigahertz in order to properly simulate the performance of a 40 gigahertz, 38 gigahertz amplifier. So the on-wafer measurements then is what we're targeting with this new module, and we're demonstrating how with a direct connect to the probes going from the module directly to the DUT, we can get a very accurate high performance measurement with good stability, good directivity, and good dynamic range in order to characterize the devices to a very extreme broadband frequency suite. So for more information, please visit us at our website at anritsu.com, and we'll be happy to provide you with the information you need that further describes this new system.